we have solved two problems, right? From this, we have completed the first part, the sum of the divisors of n, how to find. We have seen a formula. And the second one is the number of ways of expressing n as a product of two numbers. Okay. Now in this class, we will complete the remaining two questions. The number of ways of expressing n as a product of two numbers, number of ways of expressing n as product of two numbers x comma y, such that GCD of x comma y is equals to 1. Now in the previous question, this question is same again. Okay, the number of ways of expressing n as a product of two numbers, same thing, right? But here we have an extra condition that the GCD of x comma y should be equals to 1, right? So now the meaning of x, simply we wrote there this x comma y is equal to 1. What is the meaning of this? HCF, or highest common factor, greatest common divisor, GCD also you can call it. HCF of x comma y is equals to 1. What is the meaning of this? There is only one single common factor, that is the highest value, which is 1. So highest common factor is 1 means what? They have no common divisor. They have no common divisor means they are relatively prime to each other. So x comma y are relatively prime to each other. So if you don't have any common divisor, so 1 is obviously a common divisor. Other than that, if you don't have any common divisor, then HCF is going to be equals to 1. Means whatever the prime numbers, okay, what are the prime numbers or what are the divisors of x you have, that must not be present in y. There is no common divisor between x and y. Now, how you will calculate this? The number of ways of expressing n as a product of two numbers, but their GCD must be equals to 1. Now you see, for example, if you have n is equal to p1 to the power of alpha 1, p2 to the power of alpha 2, p3 to the power of alpha 3, let's say we have up to pk to the power of alpha k. So whenever you want to write n as product of two numbers, the two numbers must be divisors, which we have discussed already in the previous video lesson. In the previous video lesson, I have completed the first part and second question, right? So if you didn't see that, first go through this first and second so that you understand the third and fourth in a better way. Okay. So now, so how you will write n as product of two numbers, right? So means if you write n is equal to x into y, means obviously x comma y are factors of n or divisors of n. Okay. So now whenever you say x is a factor of n, x contains some of the primes from this list and y contains some of the primes from this list and with some powers. So for example, if I say x is equal to p1 to the power of alpha 1 and p2 to the power of alpha 2, this is x. If I say y should be p3 to the power of alpha 3, p4 to the power of alpha 4, up to so on pk to the power of alpha k. But sometimes you may have like this. Here you have p1 and here we have p2 square, and you may have here p1 cube and here something say p4 like this. Okay, then there is a common divisor. You can see p1 and p1, you can see in both, this is x and this is y. If I say, you can see a common factor p1 here and p1 cube here, so common factor is p1, then GCD is not going to be 1. So if you want to make GCD 1, what we must have is, you should not have any common divisor between the two numbers x and y. Okay, so therefore once again I'll write n is equal to p1 to the power of alpha 1, p2 to the power of alpha 2, p3 to the power of alpha 3, right? pk to the power of alpha k. Now you see, if I write n as product of two numbers x into y, so now you tell me, if you want GCD of x comma y is equal to 1, if p1 is present in this, p1 is present in this x, okay, as a product of primes, if p1 is present, then p1 should not be present here. p1 should not be present here. So therefore, if you have p1 here, means p1 to the power of alpha 1 must you have in x, then p1 to the power of alpha 1 is not going to come here in y. So let's say I take here p2 to the power of alpha 2, then p2 for alpha 2 is not going to be in x. you can have something else other than prime p2, so p3 to the power of alpha 3. So what is the meaning of this? Can you understand what we are trying to figure out here? Means if p1 to the power of alpha 1 is there, that can be in the product of x, right? Or one of the member in the product, okay, in x, and maybe in y, but not in both. So therefore you have only two choices. Either it is going to be in x or it is going to be multiplied in y. So this p1 to the power of alpha 1 is going to sit in the product of x or in the product of y. So therefore p1 to the power of alpha 1 we have two choices. Okay, either it is there in x as a product of the primes or there in y. So there are two choices. Now similarly for p2 to the power of alpha 2, right? So this p2 to the power of alpha 2 will be there in x or will be there in y. So for p2 to the power of alpha 2 is also having two choices. So likewise, if you think for each and every prime, we will have only two choices. So for each prime you have two choices. So therefore 2 into 2 into 2, like this, how many times, how many primes are there? That many times. So into 2 k times. But in this, what will happen whenever you say p1 to the power of alpha 1 here, and if I say p2 to the power of alpha 2 here, but you may have counted this p2 to the power of alpha 2 here and p1 to the power of alpha 1 here. So therefore we have the overcounting in this. Actually it is counted twice, okay, because of p1 alpha 1 maybe in x or maybe in y. So therefore we are counting it two times. That's why we have to make it half. So which is what? 2 to the power of k by 2. K times 2 to the power of k by 2, which is 2 to the power of k minus 1. So the number of choices is 2 to the power of k minus 1. I hope it is clear. If you not following this, once you stop the video and go through again, right? Whatever I explained, once you go through it again. Okay. So therefore, the number of ways of expressing n as a product of two numbers so that the GCD of x comma y is equal to 1 is simply what? Is simply what? The answer for the question is the number of ways will be 2 to the power of 2 to the power of how many primes involved in the canonical form, right? How many primes are there in the canonical form? K primes. So therefore 2 to the power of k minus 1. This is the result. You better to remember, right? But you have to remember the logic also. The number of ways of expressing n as a product of two numbers so that GCD of x comma y is equal to 1 is what? 2 to the power of k minus 1. Now you solve the question. What is that? N is equal to 2160, and we know that this is 2 to the power of 4 into what we have actually 6 cube 2 cube and into 10, so 2 to the power of 4 into 5 and into what you get here 3 cube 3 cube. Okay, 2 power 4 into 5 into 3 cube, because of 216 is 6 cube 2 cube into 3 cube, and then one more 2 will come from the 10, so 5 into 2 power 4 into 5 into 3 cube. Now how many primes you can see here? One is prime 2, the other prime is 5, the one more prime is 3. So here we have 3 primes. So therefore the number of ways of expressing n as product of two numbers x comma y so that their GCD equals to 1 is what? Simply 2 to the power of k minus 1. K is a number of primes, number of distinct prime, 3 primes are there, so 2 to the power of 3 minus 1, which is equal to 4. So you can express 2160 as a product of two primes, as product of two numbers x comma y, so that GCD of x comma y is equals to 1, right? Now let's solve the last question. The number of ordered pairs x comma y such that LCM of x comma y is equals to n. Now first of all, you observe how you will find out LCM of two numbers whenever you know the canonical form. Let's say, for example, I have, say, LCM of x comma y. If I say n, so let's say I have one number, say m. Okay, m is equals to 2 to the power of, I have m is equal to, let's say I have m is equal to 2 to the power of something, say 3, and I have 3 to the power of 2 and 5 to the power of 4. Let us suppose like this, and n is equal to 2 to the power of 6, let's say, and 3 and 5 to the power of, let's say, 10 into 7. Okay, let us suppose you have m is equal to like this, product of these primes and this product of these primes is n. Then how you will find LCM of m comma n? You know, to find out LCM of m comma n, generally what we do, the different process you have, but the simple way is just you take 2 to the power of maximum of the prime. What is the maximum of the prime is here 6. Okay, and in this, what is the maximum power of 3 here? 2. So we'll take 3 square. And what is the maximum power of 5 between this m and n is 5 to the power of 10 and 7 to the power of 1. So this gives you the LCM of least common multiple of m comma n. Okay, so whenever you want to find out LCM of two numbers, simply we take the maximum of the prime powers. Okay, so here the prime 2 has power 3 in m and power 6 in n. So in LCM, whenever you are calculating the LCM, we will take prime to the power maximum between these two. Like for same 3 and 3 square, the maximum power is 2, so we'll consider 3 square, and 5 power 10, 5 power, the maximum is 10, so we'll take 5 power 10. Here we have 7 power 0, there is no 7, here we have 7 power 1, and the maximum is 7 power 1. So we take this, if we calculate this, you are going to get the LCM of this. Okay, so this you should know before solving this question. Okay, this is the logic of finding LCM using the canonical forms. Alright, now let's discuss how we will solve this question. Now let us suppose you have n is equals to, let us suppose you have n is equal to p1 to the power of alpha 1 and p2 to the power of alpha 2, p3 to the power of alpha 3 up to so on pk to the power of alpha k. Now you have to write n as product of two numbers again. N is equals to x into y. Now here x is a divisor of n and y is also a divisor of n. Okay, so whenever you take here, for example, if I consider p1 I took here, p1 I took here. So if you want LCM of x comma y, you have to write what? The number of ordered LCM of, sorry, here we want to write what? X comma y, LCM of, what we want? LCM of x comma y is equal to n we want. So if you want the LCM of x comma y is n, which is equal to p1 to the power of alpha 1, p2 to the power of alpha 2, p3 to the power of alpha 3 up to so on pk to the power of alpha k. That is the LCM we want. So if you want LCM is this n, then we must have p1 to the power of alpha 1, maximum power we must have either in x or in y. We must have that, because of whenever you calculating LCM, you will take the maximum power of p1. And if you want to get LCM n, means you want maximum power is alpha 1. So if I take p1 here, what you have to take here? P1 to the power of alpha 1. So 1 of x comma y must contain p1 to the power of alpha 1. 1 of x comma y must contain p1 to the power of alpha 1. So if I take in y p1 to the power of alpha 1, what I can take in place of x, in x, what I can take? You may take p1, or you may take 1. There is no problem if you take 1 also, means p1 to the power of 0. So here you see for x, what you can consider? 1 you can take, or you can take p1 to the power of 1, or you can take p1 square, or you can take p1 cube, or you can take p1 to the power of 4, or you can take p1 to the power of alpha 1 also. There is no problem, because if you take p1 to the power of alpha 1 here and p1 to the power of alpha 1, still you will get LCM, the maximum power of p1, which is alpha 1. Okay, so therefore for p1 to the power of alpha 1, how many choices you are having here? Can you count this? First choice, second choice, third choice, fourth choice, alpha 1 choice, and one more choice extra. So alpha 1 plus 1 choices you have. Okay, for x you have alpha 1 plus 1 choices related to the prime p1. But if I take this p1 to there is another way of doing the same thing. What? P1 to the power of alpha 1, instead of taking in y, you can take p1 to the power of alpha 1 in x. If you take p1 to the power of alpha 1 in x, then in place of y here, what you can take for p1? You can take p, you can take p1 power 1, you can take p1 square up to so on p1 to the power of alpha 1 in y, right? So these are the choices you have for p1. These are the choices you have for p1. So how many choices again? Alpha 1 plus 1. So therefore total number of choices to make This LCM of x comma y is p1 to the power of alpha 1. Only we are concentrating on the first prime. Okay, p1 to the power of alpha 1. So considering only p1 to the power of alpha 1, how many choices of arrangement you have? Alpha 1 plus 1 choices, alpha 1 plus 1 choices. So totally you have alpha 1 plus 1 plus alpha 1 plus 1, which is 2 alpha 1 plus 2. So related to p1 to the power of alpha 1, how many choices you are having for x comma y to choose this p1 values? How many? 2 alpha 1 plus 2. But can you observe one thing here? Whenever you are saying, once again I repeat here, you see whenever you are taking here x is equal to p1 to the power of alpha 1, what are the choices you are taking for y? What are the choices you are taking for y? 1, p1, p1 square up to so on, p1 to the power of alpha 1. In this, if I take p1 to the power of alpha 1, so this is counted in x and y. Whenever you are saying that whenever you take y is equal to p1 to the power of alpha 1, here x is also again you are taking p1 to the power of alpha 1 choice. This choice is identical, right? So this we are counting 2 times. All the remaining choices, for example, if I take x is p1 to the power of alpha 1, p1 here, but x is p1, then y is p1 to the power of alpha 1. This is a different choice, right? But here p1 to the power of alpha 1, 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 it is counted 2 times. So therefore that one choice you have to remove. So therefore out of 2 alpha 1 plus 2 choices, one is repeated extra. So therefore 2 alpha 1 plus 1 choices are there for only p1 to the power of alpha 1. Now I hope it is clear to you. N is equal to p1 to the power of alpha 1, p2 to the power of alpha 2, p3 to the power of alpha 3, up to so on pk to the power of alpha k. Now once again I repeat this. Okay, don't get bored. I'm trying to make you clear this concept. Now you see x is equal to p1 to the power of something power you have to take, and y is equal to p1 to the power of something power you have to take. But if you want LCM of x comma y is n, means you have to get p1 to the power of alpha 1. Means out of these two stars, okay, one must be alpha 1. One star must be alpha 1, because we want the maximum of these two powers. So that's why what we are doing here, one place we are fixing by p1 to the power of alpha 1, and here in place of star what you can take, 0 power you can take, power 0, or 1, 2, 3 up to so on alpha 1. You can take any one of the choice. So here we have alpha 1 plus 1 choices. Similarly, whenever you fix p1 to the power of alpha 1 here, you can take p1 power is 0, 1, 2, 3 up to so on alpha 1. So again alpha 1 plus 1 choices. So totally we have 2 alpha 1 plus 1, but one is counted extra. So that's why for p1 to the power of alpha 1, 2 alpha 1 plus 1 choices are there. Similarly, whenever you consider p2 to the power of alpha 2, we fix here, and p2 something star, we have again alpha 1 plus 1 choices here. But whenever you fix p2 to the power of alpha 2 here, then here p2 power we will have alpha 1 plus 1 choices again. So total number of choices for p2 also similarly 2 alpha 2 plus 1. So like this, for each alpha we write the same expression, 2 alpha k plus 1 for the last prime. So this is the result what we want. Okay, the number of ordered pairs of x comma y such that LCM of x comma y is equal to n is what? Just 2 alpha plus k form. Now n is equal to 2160. Canonical form of this will be what? 2 power 4 into what we have, 3 cube into 5. This is the canonical form, correct? So therefore the number of ordered pairs, the number of ordered pairs of the form x comma y such that LCM of x comma y is equal to 2160, means 2 power 4 into 3 cube into 5. What is that? What is that? This is prime power alpha 1, 2 alpha 1 plus 1, and for the second prime power is 3, so 2 into 3 plus 1, and for the third prime the power is 1, so therefore 2 into 1 plus 1. So which is equal to, for the 8 plus 1 9, into the 6 plus 1 7, into the 2 plus 1 3. So we get 63 into 3. which is 3 is the 9, 3 6 is 18. So therefore, there are totally 189 ordered pairs, right? We can write 189 ordered pairs are there, so that LCM of that x and y will become 2 power 4 3 cube into 5 power 1, which is 2160. So with this we have finished the 4 questions of this model. Now on the divisors I have covered almost the different type of questions which are very important for mains level. Alright, so thank you for watching.